Hello, uh, welcome to my channel again. I have these chargers. I've learned this circuit from Rene here in YouTube, and I use this to charge all kinds of batteries and using all types of sources to power these devices. And the idea is to use a type of Joule teeth to charge batteries. The first circuit I've made is this one. Let me try to zoom here. It's sorry, it's a little bit very white, but I think you can read this. Here I've used two TIP 41s in parallel, and this circuit was the first one I've built. Is this guy in here with the two TIP 31s and a big TV. I don't know. I found this on a CRT monitor, and then I began building other devices, and this guy here, he was a Joule teeth, a normal Joule teeth, and I've just changed the circuit to be a charger. I'm calling these universal chargers, and they are very simple to make, very easy to build. After the first circuit I've made last year, well, almost a year ago, I built this using my solar chargers. It's the same idea in here. The charging battery is in series with the coil, and the collector goes through a diode and back to the battery. So if you don't have toroids like these ones, these three ones are using toroids, you can use an air coil. This one is an air coil. Network cable winding like a Joule teeth. I have the central tap in here and the two exits in here. On this circuit, that is this box in here, I've used instead of toroid or an air coil in here, I've used just fixed inductors So you can use fixed inductors too to build these devices, these chargers. And here I've used 2N2222. After this, I made a drawing from I'm calling it a universal Joule teeth charger. This is the basic idea. Again, this is inspired from RE-EMF from Rene. And here is the basic idea of this. So you have your source voltage, a diode, the charging battery that goes to a coils. I place it here, a potentiometer, to you can control the amperage that goes to the charging battery, a resistor, a transistor, and another diode to go back to the battery. This is the idea. And here the positive of the battery and the negative of the charging battery that feeds the coils. I made one in here. Just to show how you can build these devices. Here I'm using those TV inductors, but again you can use fixed inductors, toroids, or air coils. I am using 2N2222 in here, and using a 12-volt battery, the voltage of the battery here, to charge another battery, and the voltage is in there, 9 volts. And here I have it's on a 20 milliamp scale, and I use this, guys. This device is not here. It's in my backpack. I did not found it, so I built this. This is the last version that I'm using. I use the build of this device I use to charge my batteries while I'm walking in the mountains or in the countryside. And what is different in here? Is this the version 2 of this device? I recommend this version 2 if you are using a battery, a 12-volt battery as your source, and they are very economic chargers, efficient chargers, let's say. The difference in here is that I have a protecting LED here to the transistor. Before this I was using 2N355 TIPs 41, because the 2N2222 was blowing when I use 12 volt battery to charge this, or a 12 volt power supply. And with this method you can use this circuit is very robust, and here I have the charging battery. It can be any type of battery, from lithium ion to lead acid or AA batteries, whatever. And here is a 10K potentiometer going to a 460 ohm resistor, and I'm using here a 5mm LED going to the base here, and from the collector I'm going to 2 LEDs. These are these two in here. One of them is going back to the positive of the charging battery, and the other is going back to the original battery, running battery, let's say, the VIN, okay? And I'll make a quick run on this. Let me try to put everything on the same frame. I think it's, you can see the battery is 12.03, the amp meter, and here I connecting the positive is on this yellow wire coming to the positive of the charging battery. The negative of the running battery is connected to the negative of the circuit, and the positive of the circuit I'll connect here on the negative of the charging battery. So I have 12.46, 9 volts, and connecting in here. As you can see, this LED, what I've learned is placing an LED between the 460 ohm resistor here and the base. I protect the transistor from blowing, and here are the two other LEDs. Let me try to turn this off. The two other LEDs, this one is going back to the running battery, and this other one is going to the charging battery. Here I have 100 milliamps going to the charging battery. The battery is now with 10 volts, and the running battery is with 12.45. It is a very efficient charger, and here I don't know if the potentiometer is on the maximum. Yeah, I can increase here. It's on the maximum of the minimum resistance of the potentiometer, and here the battery is 10.15. No, I'm sorry, I'm feeding this with microamps scale because this battery is almost in full charge. Is a crystal battery, so I'm feeding this with less than a milliamp. Okay, let me try to change things in here. I don't have any discharged battery. Yeah, I may have one. Let me change this battery, the charging battery. Okay, now I am with other battery. It is with is this one, 4.17 volts, and let me try to here. And now connect the positive of the circuit to the negative of the charging battery here. Now I'm charging the battery with 4 milliamps, 4.19, and the running battery is with 12.43. Here the two LEDs, one going to the running battery and the other to the charging battery, and here the protecting LED for the transistor. And I can here, let me show the amperage. It's climbing 6.7 milliamps, as the voltage also is climbing. And this way I can use a 2N2222 to charge even lead batteries using 12 volts as a source. So again, here is the circuit. I'll try to place the circuit on the description, but let me try to zoom in here. The values in here: 10K potentiometer, 460 ohm resistor, a 2N2222. Here you can use any type of transformer you have, the two LEDs, and the charging battery. That can be, it always use a higher voltage than the charging battery. Again, 6.2 milliamps going to the battery is now with 4.33 volts, and the running battery is 12.3. Well, that's it. I hope this helps. How to build these universal chargers. I'll try to place the circuit on the description, and thanks for watching. Thank you for subscribing, and that's it. See you on the next project. Oh, again, just use this LED as the second one here that goes back to the running battery if you are using a battery as a source. Okay, if you are using a power supply, cell phone power supply, a notebook power supply, a solar panel, or whatever, remove this connection from the collector to the voltage in. Okay, like this. Just remove this connection and the LED from the circuit, and then you can run it safely. Now I'm charging with 26 milliamps the battery, and again this LED in here from the resistor to the base is to protect the transistor. If you are not using this LED in here, you must use a stronger transistor like a TIP or a 35.5 or whatever, but do not use a 2N2222 because you can or may blow your transistor. And in here, instead of using an LED, you can just place a diode. Preference if you have one, a Schottky diode. Well, that's it. Thanks for watching.